Today we will see different types of systems. Another two important definitions, that is intensive and extensive properties, and the third concept is state of a system. Now, first classification of systems is based on the number of phases. In the earlier lecture, we have seen the definitions of systems, then phases. What is system? System is nothing but portion of the matter which is under thermodynamics study. Whereas phase is nothing but uniform or homogeneous, physically distinct and mechanically separable part of the system. So we have seen the definitions of system and phases in the previous lecture, and again I will repeat here once, that is system is nothing but portion of the matter which is under thermodynamic study, whereas phase is nothing but homogeneous, completely uniform or physically distinct and mechanically separable part of the system. Now, depending upon the number of phases, systems are classified into two types. One is called homogeneous and another one is called heterogeneous systems. Now let us see these concepts one by one. The first one is homogeneous system. A system which is completely uniform is called a homogeneous system. A system which is completely uniform is called a homogeneous system. And this homogeneous system consists of only one phase. A homogeneous system consists of only one phase. Example, that is, say, pure liquid or some gas or air, pure air in fact, then true solutions, pure solids are all examples of homogeneous systems because they consist of a uniform part. See here, the first example here, a simple example is shown here, that is a glass. We have taken a glass and to that some water is added, pure water is added. Now that becomes a homogeneous system for me because the system consists of only one phase, that is liquid phase here. So homogeneous system is a system which is completely uniform, and in fact this system consists of only one phase. Remember always here, the number of phases in homogeneous system is only one. Coming to the next definition, that is of heterogeneous system. Here a system consisting of more than one phases, say 2, 3, 4, 5 and so on. So a system consisting of more than one phases is called a heterogeneous system. For example, ice floating on water, or a mixture of two immiscible liquids, or sand, or any solid in contact with liquid, that constitutes a heterogeneous system. Now coming to the one of the examples, let us see the first example where water is there and to that pieces of ice are added. Now these pieces of ice and water, they constitute two phases. One is the solid phase, another one is liquid phase. Now in the second example also we have a mixture of two immiscible liquids. Say water is added to oil or oil is added to water because they are completely immiscible. In the second example you can see that in a bottle or in a glass some water is taken and to that say cooking oil is added. Now here these two are different phases. So this system is an example of heterogeneous system as like the first one. Now in the third example, water is taken and to that water a lot of sand is added. Now I can find here two distinct phases. One is solid phase, another one is liquid phase. So heterogeneous system is a system consisting of more than one phases. That is called a heterogeneous system. And examples are here some solid in contact with liquid, or mixture of two immiscible liquids, or say sand in water, ice floating on water, and so on. Different examples can be quoted. So, depending upon the number of phases, systems are classified into two types. One is homogeneous system and another one is heterogeneous system. Homogeneous system consists of only one phase, or a system which is completely uniform, that is called a homogeneous system. And heterogeneous system is a system consisting of more than one phases. Heterogeneous system is a system consisting of more than one phases. Now, the another classification of thermodynamic systems is based on another parameter. So what is that parameter? That is either exchange of energy and matter. Two words are important: energy and matter, system and surrounding. Okay, two pairs of words actually are important here in all the four definitions. That is energy and matter, system and surrounding. So based on the exchange of energy or matter or both or none, systems are classified into four types. One is open system, another one is closed system, and third one is isolated system, and fourth one is adiabatic systems. Now let us see these one by one. The very first one is an open system. Now this open system is a system which can exchange both energy and matter with its surroundings. Open system is a system which can exchange both energy and matter with its surrounding. It is called open system. Let us see here examples so that the concept will be more clear. Now in the first example, we have taken beaker and to that some amount of water is added. And that beaker is getting heated from the bottom. So what will happen here? This water will start boiling and it will get converted into vapor state. Now here this system, that is nothing but combination of here water and that is water vapor, that is now system. Now this system can exchange both energy and matter. How? This energy, that is the vapor form, and this liquid water, that is the matter here in this case. So if this water is heated in an open beaker, then it can get converted into vapor state, and at that time, if the beaker is tilted, the water inside the beaker may come outside. So this particular system can exchange both energy as well as matter. Matter is here water, energy is here the vapor state of water. So such type of system is called an open system. Now consider that there is no cork here. Okay, let us in the second example consider that there is no cork, or let us suppose the reaction of say sulfuric acid with zinc pieces is carried out, that is in an open vessel. So what will happen? This zinc pieces will react with sulfuric acid and they will liberate here hydrogen gas. Now what is energy and matter here? Energy is nothing but the vapor state, that is hydrogen gas here, and matter is what here, that is zinc pieces in combination with sulfuric acid. So such type of system can exchange both energy and matter with the surrounding, that is called an open system. So open system is what? Open system is a system which can exchange both energy and matter with the surrounding. Coming to the next definition, that is closed system. A system which can transfer energy but not matter with its surroundings. A system which can transfer or exchange energy but not matter with its surroundings is called a closed system. Closed system is a system which can exchange only energy but not the matter with its surroundings is called a closed system. Now let us consider here two examples here in order to clarify this concept of closed system. Now in the first picture, I have shown here a bottle is taken and inside that bottle some liquid is there. Now this liquid which is present inside this bottle cannot be exchanged with the surrounding because it is covered with this particular lid. So that constitutes an example of closed system. Now in the second example, I have shown here a very common example given in thermodynamics, that is a gas enclosed in a cylinder fitted with a weightless and frictionless piston that we will see in the due course. So here what happens? The system can exchange energy but not the matter with its surrounding. How? Because see in the first example, if this liquid which is covered with this lid inside this bottle, if that is heated from the bottom, what will happen? The liquid inside this bottle will get hot and it will try to transfer its heat energy to the surrounding through this glass. But unless and until I open this lid, it will not be able to exchange matter, that is nothing but the liquid inside this bottle, with its surrounding. So it is a closed system. And similar to that, this gas taken in a cylinder and fitted with a weightless frictionless piston is a closed system. So a closed system is nothing but a system which can exchange only energy but not matter with its surroundings is called a closed system. Now the third definition is of isolated system. What is isolated system? A system which can exchange neither energy nor matter with its surroundings is called isolated system. Isolated system is what? A system which can exchange neither energy nor matter with its surroundings is called an isolated system. Say, for example, this picture is very common, that is called a thermos flask. Now inside this thermos flask, let us have some drink, that is hot water or say even hot water or cold water or some tea or coffee. Now this will constitute an example of isolated system because the water or tea or a coffee which is kept inside this inside this thermos flask will be continuing to keep its temperature constant. So this constitutes an example of isolated system. Now up till now we have seen three definitions, that is open system, closed system and isolated system, depending upon exchange of energy and matter with its surroundings. Now the fourth definition is of adiabatic systems. Now this adiabatic system is somewhat different. The definition of the adiabatic systems is somewhat different rather than the previous definitions. So what is this adiabatic system? A system in which no heat enters or leaves out of the system is called adiabatic system. A system in which no heat enters into or leaves out of the system is called an adiabatic system. Here the total heat content of a adiabatic system remains constant. And in practicals, there is no perfect example of this adiabatic system. But for the sake of understanding, a hot liquid taken in a thermos flask may be considered as an example of adiabatic system. So, adiabatic system is nothing but a system in which no heat enters inside or leaves out of the system is called an adiabatic system, and there is no perfect example of an adiabatic system. But for the sake of understanding, a hot liquid taken in a thermos flask may be considered as an example of adiabatic system. Now, having looked upon the classification of systems, now it becomes essential to study the different types of properties of a system. Now, what are these properties of system? Now, in physical chemistry, the properties of system are, say, pressure, volume, or that is temperature, number of moles, or say any other properties, viscosity, surface tension, melting point, boiling point. So these are all examples of properties of system. Now we see what are intensive and extensive properties. Intensive property, a property which is independent of quantity or amount of matter present in the system. A property which is independent of quantity or amount of matter present in the system is called an intensive property. Remember here the word intensive, I standing for independent. I independent. Okay. So a property which is independent of amount of matter or quantity of matter present in the system is called an intensive property. Example: density, refractive index, temperature, that is melting point or boiling point, viscosity, etc. Now, why these are intensive properties? Now, consider first the density. Now, if you are measuring the density of water, it will not affect the value of density even though we use either 1 ml water, 2 ml water, 3 ml water, 4 ml water. Okay, so the density of 1 ml water is same, density of 10 ml water is same, 100 ml water is same, 1 liter water is same. Similarly, the refractive index. Suppose we are measuring the refractive index of a particular liquid, then that is going to be constant and that is independent of quantity of matter, amount of matter. So again, that refractive index is an example of intensive property. Now the third example is temperature. Now melting point, that can be either melting point or boiling point. Now let us consider simple water as the example, or any solid. So even though whatever may be the quantity of that liquid or solid taken, that will melt or boil at a particular temperature which is called its melting point or boiling point. So temperature here is an intensive property that is independent upon amount of matter present in the system. Again, the viscosity. The viscosity of these viscous liquids or viscosity of any liquid will be again independent upon the quantity of matter which is present in the system. So that is called again intensive property. So intensive property is a property which is independent of quantity or amount of matter present in the system. That is called an intensive property. And the next definition is of extensive property. A property which depends upon the amount of substance present in the system. A property which depends upon the amount of substance present in the system is called an extensive property. Here, this property depends upon the amount of substance present inside that system. See how? Energy. Now let us suppose this energy is kinetic energy. So suppose we are having particles of different masses. Suppose we are having particles of different masses and they are moving with the same speed. Let us suppose we have particles of different masses but they are moving with the same speed. What will happen? That energy will be different in different cases because that is given by half mv square kinetic energy. Here we are considering the example of kinetic energy for this energy term. So the kinetic energy will depend upon mass. Again, the another term, that is mass. Mass is nothing but collection of particles inside the system. That is called mass. Then volume. Volume will also depend upon the quantity of matter present in the system. Now here 1 ml water will occupy some volume, 5 ml water will occupy certainly different volume, 10 ml, say 100 ml water or 1000 ml water will occupy different volumes. So here volume or mass or energy which are dependent upon the amount of substance present in the system are called extensive properties. So, intensive property is independent upon quantity of matter present inside the system, and extensive property is a property which depends upon the amount of substance present in the system. That is called an extensive property. And we have seen here different examples of different property, that is intensive and extensive property. Now, the third term in this lecture is state of a system. Now, a system is said to be present in a particular state. Remember the words? System is said to be present in a particular state when all its variable parameters or properties such as temperature, pressure, volume and composition are fixed and do not change with time. A system is said to be present in a particular state. A system is said to be present in a particular state when all its variable properties such as temperature, pressure, volume and composition are fixed and they do not change with time. Now, in thermodynamics, we define a system with some thermodynamic parameters. And what are these thermodynamic parameters? That is, say temperature, pressure, volume or number of moles, that is the composition. Now, suppose if we have a state A, another state B, state C, state D, state E. Now, when to say that system has changed its state from state A to state B? We say that the system has changed from state A to B if either 1 or 2 or 3 or all of these parameters, the values of all these parameters which define that particular system are different, are different, then we say that the system has changed its state. Now look at this state A and state B. Here temperature is T1 and here temperature is T2. Now here pressure, volume and number of moles, pressure, volume, number of moles, they are remaining constant here in this state A and state B. So even though we say that the system has changed its state from state A to state B. Now if these two parameters are changed, say temperature and pressure are changed to T2 and P2, keeping the volume and number of moles as the same as in the case of first example, then also we said that system has changed its state. Or suppose we change here temperature, pressure and volume, say temperature, pressure and volume to state D. Then even in that case also we say that the system has changed its state. Now, suppose here all the parameters are changed, say temperature, pressure, volume and number of moles, say temperature, pressure, volume and number of moles. So even in that state also we say that the system has changed its state. So a system is said to be present in a particular state when all its variable properties such as temperature, pressure, volume and composition are fixed and they do not change with time. And if either one or several parameters do change with time, then we say that the system has changed its state. So this was regarding the state of a system. So what we have seen today, we have seen the different types of systems based on the number of phases, different types of systems based on the whether there is exchange of energy or matter or both or none with the surrounding, and the third term is state of a system. So today we stop here.